Hello engineers, welcome back. In the previous video, we learned about loops in C++. In this video, we're going to study an important topic, which is functions. Okay, let's get started. So in this video, we're going to learn about functions. We'll see what functions are. We'll understand the structure of a function. We will understand what is pass by value, what is pass by reference, and we will try to understand what is variable scope. Okay, let's get started. So we touched upon functions in our introductory video when we discussed stack memory, and we also discussed in the main structure of a C++ program that main function is the prerequisite function to start execution. But what is a function? So functions are simply, I can say, a block of code that performs a task. That performs tasks. So it can be one task, there can be multiple tasks, but imagine it like a block of code that does something. Okay, so why are functions useful? What are the advantages? So when we have long pieces of code, right, we need some way to organize our code. So if we put everything in a main function, let's say we are building a large scale application and where we have tens of thousands of lines of code, we can't put everything inside the main function. So we need some way to organize functions and organize our code, and that's where functions come in. So they help with modularity. Modularity is dividing code into a bunch of code blocks, dividing into code blocks so that we can organize our code in a better way. Okay, another useful advantage is it helps with reusability. Now, because these functions have names and they can be referenced through these names, and because they have names, we can call them multiple times, and they can be reused. So if we have a block of code that needs to be executed at different places in the code, we can make use of functions so that we don't have to write that piece of code again and again and again throughout our application, right? That's where our functions are quite useful. Okay, so let's talk about structure. Okay, we know already the main structure because we use the main function, but let's talk about it in a syntactical way. Okay, so this is the structure. The function has a name, and it takes some parameters, and it does some execution, some code, and then it returns something. And the data type of what it will return is predetermined. So here we have return type. So we have a name, we have parameters that it takes in, and it does something and then it returns something. So there are a few things that are optional here. The params is optional. A function can exist without params. The return type is also optional. Function may return something, function may not return something. For example, in our main function, we are returning int, but we can also have functions that don't return anything. Okay, so let's take a small example to lay out this structure. Let's use the simplest of examples. Let's say we are adding two numbers. So the name of the function would be add, and it would take two numbers. So when we take two numbers, we need to put them inside some variables and then access those variables within our code block. So let's say our two variables are a comma b, and we need to provide the data type of each of the variable. So in our case, since we are adding two numbers, let's consider them as int. And what does it do? It adds them and it returns them. So let's add them and return them. So let's say the result is a plus b, and return result. Since we are returning also an integer, our return type would be int. Okay, so this is how you can map the structure of a function. So this is the main structure and this is the example. Okay, now let's test this. Let's write our code and see how it works. Let's go to VS Code. So I've created a new file called functions, and I've laid out the basic template, and we can get started. So we have the main function. As you can see, the structure main is returning an int. Main has the name main and it is not taking any params. Now let's create another function that adds two integers. So what do we do inside? We have a result variable, result, that simply stores the addition result, and we return result. Okay, now since the execution starts at the main function, we need to access this add function from the main function. And since add takes in two parameters, we need to create these two variables and then give it to add. Okay, let's do that. Let's say int a is 10, int b is 20, and add, so let's call that function add a comma b. Now add a comma b will return a result, so we need to save this result somewhere. So let's create a result variable here also, and then result will store this. Okay, and then let's see out our result. Let's add a small quote. Okay, let's run this function. Okay, as you can see, result is 30. So how did this work? The flow of execution is, we have declared a variable a which is storing 10, another variable b which is storing 20, and then we declared a new variable called result which is holding garbage value as of now. And then when we are saying result equal to add a comma b, the right hand side of the operator is getting executed first, and the flow goes here. And when we are coming here, it this add function takes two parameters as input, a comma b, and it is adding a and b and storing that in a result variable, and we are returning that result variable, and the flow comes back here. This result value is getting stored in this result variable, and we are just simply printing out the result. Okay, now this is a simple example. We can further simplify this. We don't need to use so many variables. Let's say we don't want to use the result variable. I can simply do this. I can simply say return a plus b. This works in the same way, and I don't need to create another variable, give it memory, and do all that. The addition happens here, and whatever is the result will get returned here. Okay, just to simplify our code, it works the same way even if you use the result variable or not, and it works the same way. Okay, here also we can avoid this. These two lines of code, we can combine them into one line. Let's say I can do this, result equal to a comma b. Since we know that in operators, this is assignment operator, so value on the right side will get assigned to the variable on the left side. So since the right side value is calling a function, we go here, and when we get the variable result, and then we simply assign that to the result variable here. Okay, Let's run this, and it still works the same way. Okay. There's another thing we can do. If we completely want to avoid this result, we can simply call this add function here itself in the cout block. Then we can completely avoid the result. Let's run this code, and it still works the same way. Okay. There are different possibilities. So you need to stick to a level where the code is more readable, and uh, if somebody else is reading your code, they should be able to understand. So this statement is little complex for me, so I will just undo this, and I will come to this level and leave it at that, because this is uh, um, more readable than adding the add function here inside the cout, which is already a quite a big statement. Okay, so that's a simple example of addition. Now here one more thing to notice, I don't need to use the same names as the passing variables here. Okay, I can possibly choose a different name. They don't need to be the same. For example, here the variable names are a and b inside the main function, and I'm passing a and b here, but here they can be and some other name. They can be c and d, and I can do c and d, and it still works the same way. See, so you need to understand what is happening here. So let's take this piece of code and go to our whiteboard. So let's understand what's happening inside the memory, right? So this is our RAM. So what is happening in this line of code? We are getting 4 bytes of memory, and those 4 bytes are holding the value 10, and the name of this is A. And we have another uh, memory block, and that is holding 20, and the name is B. But when we are saying add A comma B, sorry, when we are simply saying add A comma B, what is happening here? The value the compiler will check the structure of the defined function, right? Since the add function is taking two variables c and d, what it does is it allocates two memory blocks, one for c and one for d, and whatever is the sequence you passed in, so you're passing a first and then b later, so a gets copied into c and b gets copied into d. So there is C here, so C will get 10 and then D will get 20. Okay, these are new memory blocks, and then these two memory blocks are used within the add function, and then when we do C plus D, those two values are getting added and then we return it. Okay, that's why we don't need to necessarily use the same name, because they are not the same memory block anyway. Okay, so that's something to note of. So now that we understand the main structure of a function, let's understand the next topic, which is pass by value and pass by reference. Okay, this is a little interesting. So coming back here, as you saw that A and B are different memory blocks and C and D are different memory blocks. So inside the add function, if I change the value of C and D, let's say I have given something like C equal to C plus 10 and D equal to D plus 10. So what will happen? So C gets added 10, so C will become 20 and D will become 30, and the result will be 20 plus 30, 50. But the values are A and B, values of A and B are still 10 and 20, right? Let's check this in code. Let's say I am changing the values of C. C equal to C plus 10, D equal to D plus 10, and then we are returning C plus D. Here, after the result, let's print A and B also. A is A, B is B. Let's run this code. You see the result is 50 because now the value of C is 20 and the value of D is 30. The total is 50, but the value of A is still 10, the value of B is still 20, because that's what we have initialized them to, right? So when we are passing the variables to this function like this, the values are getting copied into new variables, into new memory blocks, but the original variables are not disturbed. Okay, so this type of passing is called pass by value. We are simply passing the value. Another type of passing is pass by reference. Pass by reference. Let's say I want these values to be disturbed. I want to do something to the original variables. So how do we do that? We know that every memory block has an address. There is some hexadecimal address given to this. There is some hexadecimal address given to this. So instead of passing the value, I can pass this address. I can pass this address. And when I pass this address, new memory blocks don't get created. New memory blocks don't get created, but the address is passed, and when I access variables within the address, I can also manipulate them within the address. Okay, so let's write the code first, how it works, and then I will come back to the whiteboard and see the inner operation. Okay, so let's say I want these two values to be manipulated. In order to pass the address, I need to use the AND operator, and whenever we are passing addresses, we know that we need to store them in something called pointers. So we need to give a star here and a star here, and when we give star C, what is the data type of a pointer? It will store memory addresses. So this star C can hold hexadecimal values. What hexadecimal value? It will store the hexadecimal value of the variable A. D will store the hexadecimal value of the variable B. Okay, and how do we manipulate the values? You simply put star everywhere. Whenever you are using that variable, you simply do star. So that's something you will get used to as you keep using pointers. So whenever you're using star C, use star C everywhere. Whenever you're using star D, use star D everywhere. Okay, now what should happen? The result would still be the same. I will still get 50 because I'm manipulating the values from 10. I'm changing it to 20, and from 20 I'm changing it to 30. So the result would still be 50, but the value of A and B would now be changed. That's what I'm expecting. Let's run the code and see. You see that the result is 50, but now the value of A is 20 and the value of B is 30. Previously, A and B were not disturbed, but now they got manipulated. So let's understand this on our whiteboard. Let's take this new piece of code and go here. And let's understand what's happening in the RAM. Now, in this line, we are getting a new memory block, and that block is holding the value 10. And in this line, we are getting a new memory block. That value is 20, and it is having the name of B. And when we say add at the rate A at the rate B, new memory block is not getting created for C and D, no, but the hexadecimal values. Let's say this value is H100 and this value is H200. H100 and H200 are being sent to the add function. So star C is holding H100, star D is holding H200. Okay, and when we want to access the values, we use the star operator, and when we use the star or asterisk or whatever you want to call it, we are able to manipulate whatever is available at this address. So when I am saying star c equal to star c plus 10, the compiler comes here and checks what is the address h100. Okay, well, what is in h100? The value 10, and it will change that value from 10 to plus 10. Similarly for b. Okay, and since these two values are getting manipulated in the memory itself, when we return and when we are printing a and b, now a's value is 20 and b's value is 30. This type of passing is called pass by reference. Okay, so when we want the original variables to be manipulated in the memory block, we use pass by reference. When we don't want them to be manipulated, we simply use pass by value. Both have their own use cases, so whenever we see such use cases, you will understand why they have given two types of options to pass. Okay, and the data types also can change. Here we have only taken the example of an integer, but you can imagine all the data types that we can pass. When we studied data types, we studied about char, bool, and structures, classes, and everything, right? So everything can be a return type, and everything can be passed by value and by reference. Okay, if you can even pass complete arrays, vectors, and things like that into functions as well. Okay, not just single variables. Okay, so we will see all those when we discuss those topics independently, but just to give you a foundation of functions. So we have functions, and they are pieces of code, and they can be reused. Okay, now the last topic is variable scope. Now, to understand this better, let's go back to our state where we used pass by value. Okay, I'll simply comment this out and I will return to a place of pass by value. Let's not manipulate anything and simply return c plus t. Okay, we are in pass by value. Now we are passing a and b, and since we know that whenever we are getting new variables, there is new memory being assigned, right? So when I'm doing c equal to c plus 10, what is happening to c? C, the value of c is getting added, getting incremented by 10, but this c is only valid within this block of code. So let's just take this line of code and come to whiteboard. So when there is a new memory block for C and when there is a new memory block for D, when we are inside this code block, the C and D variables are available in the memory. There's a value C and then there's a value D, and these two are inside the memory of add function, and this little guy is part of the stack which is sitting on top of the main function, and main function already has a comma b, right? So this whole thing is the stack memory, and we are inside the add function now, and the c and d variables are available here, and then when we are returning, this is the end of the function. So this block of code, this block of memory is no longer required, so this will get removed. Okay, so the variable scope is like that. So when we are saying c and d, we are using them only within this scope, only within this line of execution, this block of execution. So when I try to access C, what should happen? Because this block of code does not know about C variable, we should see a compilation error because main doesn't know what is C. Let's run this and find out. error generated, undeclared identifier C. But when I try to print C here, I'll simply use this statement. When I try to print C here, this works because this little function, this little guy knows what C is, but this guy does not know what C or D are. Okay, so that is how the scope of those variables are managed inside the compiler. Okay, and that is, you can think of them as their lifetime. So when this new function gets created, there's a new memory assigned to that function, and the whatever are the memory requirements for that function. Here we have required two variables. We have asked for two variables. We could be asking for 100 variables, and those, that memory space is getting allocated for that function, and those 100 variables live in that function, and they expire as soon as the function returns and comes out of the execution. Okay, so that is variable scope. Okay, so we have come a long way. We talked about functions, why they are useful. We talked about the structure. We talked about pass by value and how do we pass by reference using pointers. And we have discussed variable scopes. There's just one more point I want to show you. Now, this name add, this can also be reused. Now we have two variables. What if I want to add three variables? I can use the same structure and I can say int e, int e, and that returns the addition of three variables. Okay, and let's say I have int c is 30, and I can simply do this result 2 equal to add a b c. What happens now? Let's see. I can do result 2, result 2. Let's run it. I have made a mistake. Result 2. Sorry, it's a spelling error. So now you see, result is 40 for addition of two numbers. Result is 60 for the addition of three numbers. And I have used the same function name here. Well, the only difference is this has two parameters and this has three parameters. Right? So I'm able to use the same function name for performing different types of tasks, and they are returning different things, and they are differentiated by the number of variables or the type of variables. So maybe my third one would have been or let's say my second variable can also be like this. Maybe my second variable is a float, and when I pass the float variable to this add function, this function gets executed. When I pass two integers, this function gets executed. When I pass three integers, this function gets executed. So the compiler knows depending on the definition of the function. So this is the function definition. We are giving it a name, and we are also telling what type of variables it takes in and the number of variables it takes in. So depending on the structure, the compiler is able to decide where to send it. So when we are in this line of code, int result add a comma b, we are sending only two integer variables. So compiler is checking where is such a function that is taking two integer values, and it knows, and it goes here. And when we are doing this line of code, we are asking it to add three different integers. So it is checking which function definition has three integers, and it comes here and it executes this line of code and it returns the addition of three integers. Okay, this concept is called function overloading. overloading. So you can use the same function name to perform different things uh, for different types of inputs, right? So that is function overloading. So I think this is a good enough introduction to functions, good foundation. So my request to you would be to practice functions, and we have used integer as a data type for all our examples. Try to use character, try to pass character and try to manipulate it and then return something else, and yeah, try to pass values by reference and see how pointers work, and then play around with variable scope. And if you have any questions at any point of time, you can ask me. Okay, so that's it for this video, and I will see you in the next one. So meanwhile, don't forget to bookmark the playlist, don't forget to leave a like, and thank you so much for watching. I'll see you in the next one. Cheers.